last section, we just scratched the surface of probability and looked at the probability of some simple events. In this video, we're going to be looking at some more complex events and how to calculate their probabilities. And we're going to start off with kind of a classic probability problem, and that has to deal with the American roulette wheel. When playing American roulette, the attendant spins a marble that lands in one of the 38 slots in a revolving turntable. The slots are numbered 1 to 36, with 2 additional slots labeled 0 and 00 that are painted green. Half the remaining slots are colored red, and half are black. In roulette, the slots labeled 0 and 00 are not considered as even or odd. Find the probability that the marble will land in a red or even number. This is somewhat similar to a problem that we worked in the last section, but it's a little more complicated. But we'll look at the probability of a red is 18 slots out of 38. And the probability of an even number, also 18 out of 38. Okay, but red and even are not necessarily the same. So we got to figure out, we want to know the probability of red or even. And so we're going to look at the probability of red plus the probability of even minus the probability of red and even. So to solve this problem, we need to know how many of the red slots are also even numbers. And so we find out that the probability of red and even is 8 out of 38. So we're going to substitute numbers here. We've got 18 over 38 plus another 18 over 38 minus 8 over 38. And if you wanted to make this a little simpler, you could leave out the 38s until after you've done the addition and subtraction. But I've got 18 minus 8, that's 10 plus 18. So this would be 28 over 38. And then I could reduce that to 14 over 19. And you might notice that these probabilities work in very much the same way as sets. Pause the video now and work on checkpoint 1. We've done several problems where we rolled one die. Now we're going to move up in complexity a little bit and roll 2 dice at the same time. Suppose 2 fair dice are rolled. Find each of the given probabilities. The first die shows a 2, or the sum of the results is a 6 or 7. So we need to think about all the possibilities we can get rolling 2 dice. So let's say 1, 1. We can get a 1 and a 2, a 1 and a 3. And we're just going to continue on this way until we have all the possibilities. And because we talk about the first die and the second die, that means that 1, 2 is distinct from 2, 1. Those are not considered the same thing. Okay, so here are all the possible outcomes for this event of rolling 2 dice. And the first one we're going to find, the first die shows a 2, or the sum of the results is 6 or 7. So if the first die shows a 2, that would be this row. And so there are 6 events in that row out of 36. Now let's look for the sum of the results is 6 or 7. Well, in this first row, that would be this one and this one. That's a sum of 6. That's a sum of 7. And then here and here. And we're just going to continue on in this fashion until we get all the way down to this corner. Okay, and so I marked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. However, some of those, these 2, were also in that first set, so we have to subtract them. We counted them twice. Okay, so now we have 6 plus 11 is 17 minus 2 gives us a total of 15 over 36. That can be reduced by a factor of 3, so that would give us 5 over 12 for my probability. Okay, let's look at another situation using the same sample space. We want to know what's the probability that either the sum is 11 or the second die shows a 5. Well, second die shows a 5 is all of these. And the sum of 11, let's get something different here. That would be this one and this one. And there isn't any other. So there were 6 here, 6 out of 36, plus 2 out of 36. But this particular one was in both sets, so we're going to subtract 1, which gives us a total of 7 out of 36. Pause the video now and work on checkpoint 2. If the situations we describe, the events, are disjoint events, then we can simplify our addition rule for probability, because the intersection of disjoint events is the empty set. So I could say for disjoint events, the probability of, let's say, E union F is equal to the probability of E plus the probability of F. And it is important to remember this only applies if the 2 events are disjoint. Let's look at an example of this. Assume that the probability of a couple having a baby boy is the same as the probability of the couple having a baby girl. If the couple has 3 children, find the probability that at least 2 of them are girls. So we're going to say that the probability of a boy is 0.5 and the probability of a girl is also 0.5. And then they ask us about what's the probability that at least 2 of the children are girls. So we have to cover a family that has 2 girls and a family that has 3 girls. So going back to our tree diagram that we did in the last section, we could have boy, girl, 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 boy, girl, 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 boy, or we could have 3 girls. So we have 4 chances there. And if you remember, there were 8 possible combinations. So the probability of 2 girls or more is 4 out of 8 or 1/2. Pause the video now and work on checkpoint 3. Let's look at another rule called the complement rule, which tells us that the probability of the complement of an event is equal to 1 minus the probability of the event. So we could rewrite this and say that the probability of the complement, let's put that in here, plus the probability of the event is equal to 1. That means either the event is going to happen or it's not going to happen. When you add those together, you get something. Certainly something's going to happen, so it's 1. Let's look at an example. If a fair die is rolled, what is the probability that any number but 5 will come up? Well, we know that the probability of 5 is 1 chance out of 6. So the probability of the complement of 5, which is everything else, has got to be 1 minus 1 over 6, or 5 over 6. So pause the video now and work on checkpoint 4. Here's another example where it's easier to find complement than to find the actual event. If 2 fair dice are rolled, find the probability that the sum of the numbers showing is greater than 3. Well, we just saw a little while ago that there's 36 combinations. Most of them are greater than 3. So let's think about the ones that are not greater than 3. I could have a 1 and a 1. I could have a 1 and a 2. Or I could have a 2 and a 1. Those are the only 3 possible events that are not in this event of the sum being greater than 3. So the probability of the sum greater than 3 is equal to 1 minus the probability that the sum is less than or equal to 3. We have to look at our wording carefully to decide whether the equal goes here or here. But we've already seen that the probability less than or equal to 3 is 3 out of 36. So I've got 1 minus 3 out of 36. Let's reduce this down to 1/12. And 1 minus 1/12 will give me 11/12 for the probability of a sum greater than 3. Pause the video now and work on checkpoint 5. Sometimes, instead of stating the probability of an event, we talk about the odds. Okay, odds are closely related to probability, but they are calculated a little bit differently. Odds can be odds in favor or odds against. So we're going to look first at odds in favor. And odds in favor of an event is the probability of the event happening over the probability of the event not happening. Assuming, of course, that the probability of the complement is not 0, because we still can't divide by 0. So, suppose the weather forecaster says that the probability of rain tomorrow is 1/3. Find the odds in favor of rain tomorrow. So the probability of the event is 1/3, and the probability of the complement is 2/3. So I can multiply both of those by 3 and get 1/2. And we would write this as 1 to 2, or with a colon, 1 to 2. Okay, so the odds in favor of rain are 1 to 2. Now let's look at the odds against. So this is the odds that it will not rain. And this time we're going to put the probability that it will not rain divided by the probability that it will rain. So this is 2/1, or we would say 2 to 1, or 2 to 1 against. So I would say the odds against rain are 2 to 1. Now these were pretty simple examples. Let's look at something else. Let's say the odds in favor are 3 to 5. I want to work backwards from that and find what's the probability of this particular event. Well, I have 3 and 5, so it must have been 3/8 over 5/8. So the odds in favor would be 3 to 5, but the probability of the event, whatever it is 3/8. Another way to say this, the probability of an event is equal to m over m plus n, and the probability of the event not happening would be n over m plus n. And this is if the odds in favor is that top number. Let's look at another example dealing with odds. Often, weather forecasters give probability in terms of percentage. Suppose the weather says that there's a 40% chance that it will snow tomorrow. Find the odds of snow tomorrow. So the probability is 40%, which is 40 over 100, because percent means out of 100. So 40 chances out of 100 that we'll have snow tomorrow. Okay, using our odds, we're going to have 4 over 4 plus 6. And so if that's the probability for my odds in favor, we'll write it this way, m over m plus n. Well, this m was 4, so n must have been 6. So we say the odds in favor are 4 over 6, or let's reduce that to 2/3 and say 2 to 3 in favor, or we could write it 2 to 3, like that. It's important that we reduce the fraction to lowest terms so that we understand whether my answer is equivalent to somebody else's. If they're both reduced to lowest terms, it's much easier to compare. So pause the video now and work on checkpoint 6. Let's work now on going from odds back to probability. So the odds that a particular bid will be the low bid are 4 to 5. So the odds in favor, 4 to 5. Find the probability that the bid will be the low bid. So to find the probability here, I need to have 4 over 4 plus 5, or 4 over 9. Now that fraction's already reduced, so I can just leave it that way. Now let's look at the odds against. Okay, if the odds in favor were 4 to 5, the odds against were 5 to 4. So that would give us 5 over 4 plus 5, which is 5/9. And again, that's reduced, so I don't need to do anything more with that. Pause the video now, work on checkpoint 7. Let's wrap up with a couple of real-world examples on probability. Let A represent that the driver in a fatal vehicle accident was age 24 or younger, and let B represent that the driver had a blood alcohol level of 0.08% or higher. In most jurisdictions, that's legally drunk. From data on fatal crashes in the year 2015 from the U.S. National Highway Traffic Safety Administration, we have the following probabilities. The probability of A is 0.1882. So this is the probability that a driver in a fatal accident is 24 or younger, almost 20%. Okay, and then the probability of B, which is that the driver was legally drunk, is a little bit lower, 0.1648. And the probability of A intersect B, so the driver's both young and drunk, is 0.0330. Now we want to find the probability that the driver was 25 or older and had a blood alcohol level below 0.8. So we want to find the probability that neither of these things happened. Okay, older driver, not drunk. We're going to work on this problem using a Venn diagram. So we'll call this event A and this event B. And A intersect B is, just going to draw an arrow there. It's this 0.330. And then the part of A that doesn't include this would be 0.1882 minus 0.0330. So 0.1552. So this is 0.1552. And then for this area, we do the same thing. 0.1648 minus 0.0330. And so I have 0.1318 on that side. And so now what is this area out here? If I subtract all three of those areas, I see that this is 0.6800. And the probability of the entire Venn diagram has to be 1, and that's how I can get this. Okay, so the probability that the driver in a fatal crash was 25 or older and was not legally drunk is 0.6800. So even though we talk a lot about young drunk drivers causing a lot of accidents, almost 70% of them still are caused by people who don't fit that profile. And now we're going to find the probability that the driver was 25 or older, so A complement, or had a blood alcohol level below 0.8%. So this is a little bit different. I'm looking at A complement union B complement. Well, A complement is this whole area out here. B complement is this whole area here. So this is going to be 0.6800 plus this area 0.1552, because that's part of B complement, plus 0.1318, that's part of A complement. When I add all of those together, I get 0.9670. Pause the video now and work on checkpoint 8. Sometimes it's helpful to use a table to figure probabilities, particularly if things are not equally likely. Data from March 7 2017 for all 505 stocks in the S&P 500 regarding the price of the stock and the dividend yield are cross-classified in this table. The price of the stock is categorized into three groups: 0 to $49.99, $50 to $99.99, and $100 or higher. The dividend yield is categorized as to whether there was no dividend, a dividend yield between 0.01% and 1.99%, or a dividend yield of 2% or higher. So that information is all in this table. Part A says, let E be the event that the dividend yield is 2% or higher. Find the probability of E. So I can look at this column. For 2% or higher, the numbers are 68, 102, and 45, which gives me a total of 215. And we were told that the S&P 500 actually has 505 stocks in it, so it would be 215 over 505. And then I need to reduce that. And it is approximately 0.4257. Okay, Part B asks, let F be the event that the price of the stock is between $50 and $99.99. Find the probability of E intersect F. So we find the information about price between $50 and $99.99 in this row. It's summed up for us as 207 out of the 505 stocks were in that range, which is 0.4099. And then we have to know what's the probability that it was in both this row and this column. There were 102 stocks there. So 102 out of 505 is going to be pretty close to 0.2. And they give us a number actually 0.2020. So the intersection between this and this is going to be this, with the decimal point. Okay, one more of these. Find the probability of E union F. Okay, so that's going to be the probability of E plus the probability of F minus the probability of E intersect F. So the numbers that we had before, 0.4257 plus 0.4099 minus 0.2020 gives us a total of 0.6336. So this is the end of this video. Go ahead and work on checkpoint 9 and then move on to your homework assignment.